All right, guys, today we're going to be doing some practice problems from Chapter 10, Section 2 of the textbook, which is all about areas of trapezoids, rhombi, and kites. Okay, guys, so we're going to start off by finding the areas of some trapezoids. Now, the formula for this is circled in green at the top right. This is area equals, half the height times base 1 plus base 2. Let's see how this works. Oh, by the way, I have a calculator handy for today. You're going to want one as well because a lot of the math we'll be doing today involves decimals, involves dividing by 2, and some other stuff that I really just don't want to have to do in my head or actually on paper. So the calculator is a great tool for that. Let's look at how this looks with the first problem here. So the first thing I'm going to circle is the height. That's pretty easy to identify. That's that 2.9 inches that represents the distance from the top base to the bottom base. The second thing we need to identify are the two bases. So we've got 1.5 inches and 3.3 inches. All right, cool. So what we're doing is we're writing out our area formula, which here is going to be 1/2 times the height, which is 2.9, times the B1 plus B2, which is 1.5 plus 3.3. Now, because we're doing inches times inches here, our units are going to be square inches. So let's multiply some of this out using the calculator. So the first thing we might want to do is add these two together. 1.5 plus 3.3, that's 4.8. So what we're doing in the calculator, ooh, that was a bad 8. What we're doing in the calculator is multiplying 1/2, or 0.5, times 2.9 times 4.8, and that's going to give us 6.96. So what we wind up here with our answer is 6.96 inches squared. Now, if I had asked for that to be rounded to the nearest whole number on an exam question, that would be about 7 inches squared. Okay, but here I'm not really asking for that. Let's go to number 2 next. I know I change up my numbering style each time, but this time we're actually going to go according to the numbers. So number 2. We see base 1 and base 2 at the top and the bottom. We also see the height is 2 inches. So this one actually should be pretty easy to do because what we're going to find is that we have 1/2 times the height, which is 2 inches, times B1, which is 0.6, plus B2, which is 2 inches. And this is going to give us 1/2 times 2 times 2.6. The reason I say, and that's going to be inches squared, the reason I say this problem is pretty easy is because 1/2 times 2, well, 1/2 of 2 is just 1. So we can actually get rid of that whole part of this, and that leaves us with our answer, which is 2.6 inches squared. Interesting question here. How would we round this? Well, it's 2.6. So if we wanted to round to the nearest square inch, we would want to go up from that, not down from that. So that would be approximately 3 inches squared. But again, that's not exactly what I'm asking for here, but I just want to get you guys to remember that idea of rounding. Let's look at number 3 now. We have our base at the top. We have our base at the bottom. 1.4 and 4 together make 5.4. So I'm actually going to already group those together in their little box there. Then I look at the height, which is 3 inches. So we can put that into our formula. And of course, we're multiplying this whole thing by 1/2, or you could think of that as dividing by 2. I think this is a great one for the calculator. You could divide 5.4 by 2, and that would give you, I think, 2.7, and you can multiply that by 3. But let's just use the calculator for this one. So what we're going to be doing again is multiplying 1/2, or 0.5, times 3 times 5.4, and that's going to give us 8.1. So I'll record that answer there. This is going to be 8.1 square inches. Okay. Now, if we wanted to round that one, it would be 8 inches squared, but we're not going to do that right here, right now. Let's look at number 4. So here the height is 2 meters. Base 1 is 1.6 meters. Base 2 is 4 meters. So what we're going to see as this comes together is 1.6 plus 4 meters is our base 1 plus base 2. We're also going to have 2 meters as our height. And of course, we're dividing this by 1/2. Now we're going to notice something similar to what happened up here in question number 2 comes again right here. So we're actually going to be able to cross out those two, and that leaves us with 1.6 plus 4 meters times the meters from over here, which is actually not canceled. So what we're going to wind up with is 5.6, and that is meters squared. Now notice if we wanted to round this, the nearest square meter, that would be 6 meters squared. And I'll stop there. Okay, guys, so we're going to next look at some areas of rhombi and kites. I couldn't find a KITE sheet for this one, but I could find a worksheet off the internet, so we're going to do 3 practice examples here. For each of these, we're going to identify first whether it's a kite or a rhombus, and then we're actually going to find the area. So our area formula, by the way, is in the top right. It's circled in green. This is area equals 1/2 times diagonal 1 times diagonal 2. And we'll walk through the process of kind of doing that for each of these. So in the first one, now, I want you guys to notice we have 2 congruent sides on the left, 2 different congruent sides on the right. So this is, in fact, a kite. A rhombus should have all the sides the same. So what we're going to do first is identify diagonal 1. That's going to be the 6 plus 6 down the middle here. So that's going to be actually 12 total. And we're also going to identify diagonal 2, which is down the middle the other way. That's also, interestingly, going to be 12. And remember that we're multiplying this whole thing by 1/2. 1/2 times, well, 12 times 12 is actually 144. So what we're going to be doing is 1/2 times 144. And if we divide that 144 by 2, that's going to give us 72. Okay, so our area for this first one is indeed 72. For this second one, notice we have 1, 2, 3, 4 sides the same, so this is a rhombus. For the rhombus, though, the area is exactly the same. It's still 1/2 diagonal 1, which we'll call this one. So 4 plus 4, that's 8, times diagonal 2. 5 plus 5, we'll call that 10. And then we can start multiplying stuff out. So what we're going to get is 1/2 times 80, because 8 times 10 is 80, and half of 80 is, of course, 40. So our area here will be 40. This is a pretty easy formula. For this last one, let's see. I'm actually going to move down a little bit because I'm having trouble seeing the 2 diagonals. So what we've got is a diagonal measuring 19 and a diagonal measuring 38. You might want to get your calculators out for this one because these numbers are kind of large. So first of all, I'm noticing that we have 2 congruent sides on the left here and here, and 2 different congruent sides on the right there and there. So this is in fact not a rhombus, but a kite. In a rhombus, all the sides should be the same length. So our area, again, is going to be 1/2 diagonal 1. Let's call that this 19 times diagonal 2, which we'll call this 38. And I want to remind everybody that it doesn't really matter which one you call diagonal 1 and which one you call diagonal 2, as long as you multiply the 2 diagonals together. So what we're going to do here is just that. We'll multiply 19 times 38. I'm using the calculator for some support on this one. And that's actually going to be 1/2 times 722. Now, if we divide that 722 in half, it's going to give us 361. So our answer here would be 361. And there is our work on areas of kites and rhombi. Next time, guys, we're going to look at some areas of regular polygons, which is going to be a bit more challenging than the work we've done these last couple of days. But we'll get through it, and I'll show you some practice examples of how to do that as we continue to build through this area unit.